Hi everyone, welcome to part 5 of the digestive. So we've talked about the mouth and now we've talked about the esophagus. So let's now talk about the gross anatomy of the stomach. Okay, so the stomach is primarily a storage tank. However, it does begin the process of digestion, primarily protein digestion. Okay, now we've talked before about when you chew your food, you've chewed it up, we now convert it into a bolus of food. That bolus of food is now coming down the esophagus and into the stomach where it will turn into chyme. Okay, now because the stomach, when empty, is about 50 milliliters in volume, it's going to have to expand when you eat, and it can expand up to 4 liters, which is like 2 Coke bottles. Okay, so this expansion is allowed because we have multiple folds called rugae. And so when you look at the picture right here, these wrinkly looking areas, that's the rugae. That allows the stomach to stretch out. Okay, let's look at the major regions of the stomach. You have at the top right here near the gastroesophageal junction on the stomach side, it's called the cardia. Okay, the fundus is this little elevated portion up here. Notice it is elevated above the level of where the esophagus comes into the stomach. Then below the fundus, you have the primary portion of the stomach, which is the body. And then below the body, you have kind of like a funnel, a big funnel. And this is going to be the pyloric region. Okay, now at the end of the pyloric region, right here, you've got another sphincter. So that sphincter is going to regulate the amount of chyme that leaves your stomach and goes into the very beginning of your small intestine that we call the duodenum. Okay, now this chyme is ejected from the stomach in small bits at a time because, remember, the inside of the stomach is going to be very acidic. The small intestine is not able to tolerate the acidity of that chyme, and so it brings it in small portions, and this portion of the digestive system actually neutralizes that acid so that it can pass through the rest of the digestive system without having any problems. Okay, let's look a little bit more. Let's look at the outside of the stomach. Okay, first off, you've got this outer greater curvature. You've got the inner lesser curvature. But then you've also got something that's not shown in this picture. You're going to have it's a type of mesentery. You've got a lesser and greater omentum. Okay, remember when we talked about the mesenteries before? It's that webbing kind of stuff that's in between or holding the small intestine to each other. Okay, so we've got a lesser omentum, which is similar to that mesentery. It's going to have fat and lymph deposits in it as well, and it's going to go from this lesser curvature to the liver. Okay, there's another mesentery that is going to come off of this greater curvature of the body, and it is our greater omentum, and that omentum will act as like a curtain. Okay, and it will fold or come across the top of or on the anterior side of your intestines. Okay, now something else I wanted to point out in this picture. Okay, we've talked about the muscularis externa. So in the muscularis externa, you've got a longitudinal and circular layers. Well, there's a little bit of an adaptation here in the stomach. Okay, so right here, we're talking about the muscularis externa. All right, you've got your typical longitudinal layer. You've got your circular layer right here, but you've got a third layer called the oblique layer. Okay, the oblique layer is not continuous, unlike the circular and the longitudinal layers. It is more inconsistent, but the three of them together are what causes that churning and pummeling of the food. Okay, so now let's move on to the microscopic anatomy. Okay, so I just mentioned the muscularis externa has an extra oblique layer with the circular and longitudinal layer. Okay, and so that helps to pummel the food as well as to mix it. Okay, so we need to mix the food with all of the substances that we're going to talk about here in a minute that are going to be secreted by these glands. Okay. The mucosal layer, remember that's the one on the side of the lumen, okay? This is going to be the simple columnar epithelium again, but it's almost completely composed of these mucus cells. Why? Because we need to have mucus to protect the stomach tissue from the acidic secretions, okay? So let me point out in this picture, you see these circles right here, right? Okay, so that is what we call gastric pits, okay? So the gastric pits are where we are going to have these glands secrete their products, and that product secretion is going to come out. Okay, so let's talk a little more about those specific glands. All right, so the first gland cells are going to be right up here in the neck of this gland, okay? So we call these mucous neck cells because they produce mucus, okay? In this case, though, it produces an acidic type of mucus. Next, we have our parietal cells, okay? Now, parietal cells are very important. These are the ones that are going to secrete the hydrochloric acid, okay? So the hydrochloric acid has a pH of 1.5 to 3.5. Now, remember, our blood is typically, has a pH of 7.35 to 7.45. So this is extremely acidic compared to our physiological normal. Okay, so now here's the parietal cells here. You see how they're just kind of dotted in here between the mucous neck cells, and they're pretty much dotted throughout the entire gland. Okay, now the purpose of this hydrochloric acid, this extreme pH, is that it helps to denature proteins, okay? When we denature the protein, we take that globular protein and then stretches it back out into its primary form, meaning individual amino acids linked together in a string, okay? It also activates something called pepsin, and we'll talk a little bit more about that later. But it also helps to break down some of those plant cell walls. And this is very important. It also kills a lot of the bacteria, okay? So the food we eat has quite a bit of bacteria in it, and it typically doesn't make us sick, but there's actually a lot of bacteria in there. But that pH of a 1.5 to 3.5 kills a lot of bacteria. They cannot live in that low of a pH. Another important thing that these parietal cells do is that they secrete an intrinsic factor. The intrinsic factor is required for us to absorb B12 in the small intestine. Okay, so remember that. You have to have the intrinsic factor from the parietal cells to be secreted into the stomach. Then when the B12 gets to the small intestine, that intrinsic factor will allow the small intestine to absorb it. Okay, let's move on. Okay, so the next type of cell that I want to talk about is the chief cells. All right, so remember when I said something about parietal cells, okay? In this picture, here's our parietal cell, okay? Now, it secretes the hydrochloric acid. When the parietal cell secretes that hydrochloric acid, what happens is it takes this pepsinogen that is secreted by our chief cells, the ones here in purple, it takes that pepsinogen and converts it to pepsin. Okay, so the chief cell secretes an inactive enzyme called the pepsinogen. The hydrochloric acid alters the pepsinogen, which causes it to become pepsin, which is the activated version. That's the one that does the degrading of proteins. Okay. Now, we also have here the chief cells also produce some lipases, but it only digests about 15% of the lipids. Finally, let's talk about the enteroendocrine cells, okay? These are in the very bottom of this gland, okay? So the enteroendocrine cells secrete, yes, an endocrine cell. It secretes a hormone, okay? So it secretes both hormones and paracrines, meaning it's going to secrete something that will act back on that cell. Okay, so the thing to know about the secretions here, as opposed to the chief cells and the parietal cells that secrete their products into the lumen of the gland for that product to then go up to the top of the gastric pit and then go into the stomach, the enteroendocrine cells will actually secrete their product down toward the lamina propria. Okay. So the products that these secrete are, two examples are serotonin and histamine. Those are our paracrines. But then the hormones it secretes are somatostatin and gastrin. And we'll talk about those later and how and their function. Okay. So moving on, let's talk about the mucosal barrier again. Okay. So here we have, right here is our tissues. Okay. Up here is the stomach lumen with the pH of about 1.5 to, let's say, 3, okay? So we don't want that pH to get down to this tissue layer. So we have that mucosal barrier that protects it with that bicarbonate-rich mucus. The bicarbonate will neutralize some of that acidic pH so that it's not quite as acidic. But another function that we have is these little black dots right here. Those are tight junctions. So that prevents any hydrochloric acid from getting in between these individual tissue cells. Also, if there is any hydrochloric acid that does manage to make it down to this tissue, these epithelial cells are very quickly replaced by cell division every 3 to 6 days. So even if you have a cell that is killed from or eliminated from that hydrochloric acid, there's another one that will replace it in just a few days. All right, so now let's look at a little bit at gastritis and ulcers. Okay, so gastritis, remember anything that ends with itis means inflammation. So gastritis is some kind of inflammation that is in our stomach's mucosal barrier. Okay, so it's caused by anything that reaches our stomach tissue. Okay, and so here's a picture of an ulcer. Okay, so you can see the tissue has been eaten away because something breached that mucosal barrier. Now, many times we have found that these ulcers are caused by a bacteria called H. pylori. These little greenish bluish structures here are actually bacteria that's in our stomach. Okay, so it's actually on top of our mucosal barrier in the stomach. And what happens is when we have this bacteria, it manages to somehow bypass that mucosal layer and it causes an ulcer. Okay, now since it's a bacteria, it can easily be treated with antibiotics. So frequently, people who have had gastric ulcers, we can go in, find out, do they have H. pylori? No problem, we'll give you some antibiotics, and guess what? Your ulcers are cured. Also, though, not all ulcers can be caused by H. pylori. If you take a non-steroidal anti-inflammatory drug, such as an NSAID or an aspirin, that can also cause ulcers. All right, so let's quickly review what the digestive processes in the stomach. We have propulsion. We deliver chyme to the small intestine. We have that mechanical breakdown of food. We have that it is a holding area for food. We have some digestive processes due to the hydrochloric acid and the pepsin. We have some minimal absorption, primarily things like alcohol and aspirin that are lipid soluble. And then we have that intrinsic factor, remember, that we need for the absorption of B12. The lack of the intrinsic factor can cause pernicious anemia. Okay, so question. Name the 4 types of gland cells and what products each of them secrete.